Okay, good to know. Good afternoon, evening, morning, wherever you're joining us from. And you're welcome to the first Python Nigeria meetup for 2024. If you're excited to be here, I just need you to do something for me in the chat section now. And that is introduce yourself with your name. You mention your name, where you're joining us from, what you currently do, and why you love Python. I know there are many reasons why you love Python. We just need one of those reasons we like to know so that we can learn from you. So I'd like you to start dropping your comments. Once I get to see yours, I will read it out for people to know you. Who knows? Because we're streaming live, somebody might meet you. Please introduce yourself. I can see some people in. Thank you for joining, Michael, Jesse Dari. People joining us on YouTube, thank you for joining. Just introduce yourself, your name, where you're joining us from, what you currently do, and one reason why you love Python. Please, I'm waiting so that we can know people are seeing this and you are also hearing us. While we do that, so while we're waiting for you to drop comments, I'm still waiting. Welcome, Clement. Welcome, Read One. But welcome, Abimbola. Please drop your name, what you do, where you're joining us from, and one reason why you like Python. Okay, sorry, give me a moment. Let me just share my screen. Okay, so why? Okay, thank you, Ridwan from Nigeria, a Python backend engineer. I love Python because it's easy to get started with. Thank you. Clement joining from Aqua Anambra State, data analyst with Python. I can do almost anything. Incredible. My name is Felix, joining from Lagos. I am a backend developer. I love Python because of the varieties of open source library to work with. Welcome, Clement, Ridwan, Kenneth, and many other people that will join us. So we're going to get started now. I know you are excited to see us after a long while, and we're also excited to kickstart 2024 with you. So 2024 has promised to be amazing, and we have a lot in store for you. So before we go ahead with today's program, I'd like to take you through our code of conduct because it's very important that we all know what we should expect. The first thing here is that we should be respectful. Whether you are talking or you are chatting, make sure that you're careful with the words you use, who you are reaching out to. That's very important. And it's also important that you're open to collaboration, working with people. I mean, as you're introducing yourselves, you might see someone you love to work with, or somebody will reach out to you saying what you do. Be open to collaborating with people, and that's something that will help your growth because you can't do life alone. So, and in the process of collaborating, show empathy. Don't do things anyhow when you want to say things to people, either online or offline. As a community member, it's very important that we show empathy, be welcoming and inclusive. You can see that people are joining us from different parts of Nigeria and also outside Nigeria. So it's very important that you are welcoming to any kind of person you have here. So we have more detailed code of conduct on the PSF website. You'll be seeing the link now, so you can check and read more to understand us. So next slide, please. To be part of this community, I know some of you are already on our Slack channel. In case you're not there, check through our website on how you can join us on Slack, or you send an email to hello at pynigeria.org. Then you can also connect with us on LinkedIn, Python Nigeria, Twitter at Python Nigeria, Facebook Python Nigeria, and YouTube. You can subscribe to our channel now. In case you are not subscribed to this channel and you're joining us live on YouTube, I would encourage you to please subscribe to our channel now. So I also like to state that on Twitter, the only the only page we associate ourselves with is Python Nigeria. So in case you're following any page or you are seeing any post from any page, just know that the only way we communicate with our community members currently is through our at Python Nigeria platform. So next slide, please. Thank you. So you know that we can't do this alone. To set up meetups, trainings, conferences, and other things, we can't do it alone. So I want us to take 2 minutes. If you're interested in volunteering, I've seen backend engineers here, I've seen data scientists, data analysts, and a, a house full of different people. Idowu from Portugal, you're welcome. Felix, and many other people that will still be joining us. Aisha, I love Python because it has the most welcoming community. Thank you. So the way you can also contribute here is by joining our volunteers, and you can do that by just picking up your phone, scanning the barcode on the screen now, or by you can also do that by using the link bit.ly/py Nigeria volunteer. So you can just type that link. I think the link has also been dropped on the chat. So you can click on it, scan the barcode on the screen to be part of our community volunteers. We cannot do it alone, so we really need you. So I know that you are here for a reason. You're here because we want to talk about safe how you can run untrusted code safely with Docker. This is why we are here. So, and we'll be having the honor of Mr. Chukwudi Unwachuku to go through this. So before I invite him to come on stage and start the section, I would like to read his bio. So take your seat, take your water while you listen to me reading his bio, so that you can know, you can understand who is coming to teach us today. Mr. Chukwudi Unwachuku is a software craftsman with many years of experience building tools that solve problems and put smiles on the face of individuals. He has worked in many industries like financials, health technology, agriculture, humanities, and telecoms. He fully understands the HTTP stack and enjoys time between hacking requests and responses. Is focused and doesn't try to learn all the shiny technologies out there. And as such, is comfortable with Python and JavaScript, with some other ones in between. Is a fellow of Python Software Foundation and a recipient of the PSF Community Service Award. He serves with the PSF in the grant team and fellow work group. As a founding member of Python Nigeria, Chukwudi is keen on seeing the community grow and supporting talent all the way. With great joy in our heart, with clapping emojis, with love emoji, and every of all those emojis I can find on your screen, I would like you to join me as I welcome Mr. Chukwudi to take us on today's section. Thank you so much for joining once again. You're welcome, sir.
Thank you, Madam Ruth. Thank you very much, everyone, for joining. I really appreciate the audience speaking with you. Please, if there's any issue with my audio, feel free to call me back. I'll be sharing my screen 100%. So let me know as it goes. I'm sharing the screen. Please hold on. I want to believe you can see everything on my screen right now. Please. If you can't see my screen, can you let me know? I'm being told the screen is okay. I think it's showing now. Okay, great. It took it a while. So Ruth has introduced me, and I wouldn't go further into that. The reason why we're here today is running Untrusted on safe code inside Docker. So I did some things. I've had these repositories, sorry, please, for a while. One is 3 years old, the other is 2 years. You can check them out on GitHub. So that's where I'll be coming from. Please do not feel overwhelmed. You will be seeing some things you've probably never seen before. If you have questions, just drop them in the comment box, okay? We would have enough time to think. But then I want to believe we have beginner, intermediate, and advanced. So if I'm too low for you, please bear with me because I'm going to go gradual to get to where I'm going to. I'll be showing code from assembly language and from Python. I am not doing it for you to learn assembly language, but for you to learn Python. What we're talking about in this case is untrusted code, codes that are not safe. How do you run them? How do you evaluate? How do you check out things? That's what we're here to learn today. The first one I'll be starting with is a code I have on this repository. You can check it out online. Here we go. I'll make this bigger. So the first one you can get pull on your end. When I'm done, I would also improve on what I have. So where do we start from? There are several ways you can run Docker. You can run it on the terminal using the Docker run, or you can use Docker Compose. So in this instance, I'm using Docker Compose and I'll be, please give me some few moments. Sorry, I was told about my lighting, so I had to adjust. Uh, don't mind my background, please. Okay, so is my screen still showing? Okay, so I want us to learn some things here. I have two Docker files, one named wu.dockerfile, the other one named no.dockerfile. So no stands for no user, the w stands for with user. So what do I want to do? I have Docker files that are doing almost the same thing, and we're going to be checking them out. So let's do a little bit introduction. Let's go to Docker. So what is Docker basically? Docker is a technology that helps us to abstract things within our system. That's the way I'll define it. I wouldn't go more than that. Now, think of container for shipment. When you have that container, you can put anything you like inside. We also associate image. There's something we call an image with this technology. It is from the image that you create as much containers as possible as you have. In this case, I would think of a baking pan as an image and the cookie that comes out from it as a container. If you have a baking pan, depending on the shape, you can do any amount of shape according to that baking pan. So if you have an image, depending on the configuration, you can do any amount of containers. That's what we're learning. So I'll be dealing with some containers. I have container here. You'll find it inside the Docker file for Debian. Debian being an operating system like Ubuntu. And then they usually have these fancy names that they name them from time to time. So I did Debian Bullseye. So I pulled Debian Bullseye. I have it on my system. If you don't, you can as well pull it. So for a confirmation, I'll just grab Bullseye and so it's no longer there. So I'll do docker pull Debian Bullseye. So I expect this. Um, okay, so it's supposed to be Bullseye. Sorry, Docker pull Bullseye. So if it's not on my system, it will pull it, and if it's on my system, okay, I see Bullseye. If it's on my system, everything bullseye would show. So I'm referring to the bullseye. It's 124 MB. It is an image. So I have this image and I would form everything I need from it. The first thing I did was to install some things inside it, like Build Essential, like Vim, GDB, NASM, being a compiler for assembly language. And then when I was done, I removed everything inside. I was fine. That's what I'm doing. And I'm calling that from Docker Compose. Please do not forget, I'm just referring to this with user. So here we go with user. I'm going to be building, I'm telling this context with a dot means you can find this file in the present directory. The dots mean the present directory. Dots mean the parent directory of where you are in. And then I give the container a name. If I don't give it a name, to give it its own name, which I may not like. I want to be able to easily refer to this and clean up things. A little bit of digress. If you see me doing things like writing DI and all those things, it's actually an alias in my system. It's either an alias or it's something I wrote that I use. So you may see me type DPA. And when I type DPA, it's actually running something like this. So if you see me typing some funny codes, they are just either an alias or a declaration that I've added inside my bash, inside a bash file that runs whenever I start my terminal. So we will proceed. There are two files. What do I want to do? I want to build and run an assembly language thing. And when I do that, don't want I don't want anything happening inside that container to affect my main operating system. So I'm going to work in it in a controlled way. So I have this variable here, tty, that is true. So basically mean keep this container running. Once it's finishes doing everything, just keep it running. That's the reason why I send this tty true. So there are two Docker files, two services that I'll be running. If, when you see if, it's just a convention I use for typing image for without user NASM. CF container for without user NASM. So I follow that convention when I'm doing my things. Then again, I'm running on Ubuntu operating system, so you would see me using Makefile a lot. I use Makefile to automate things. I use Makefiles. You see me doing shell script. Those things are just meant to ease life for me. So one more thing I want you to pay attention to is the fact that I have a working directory. I will really explain these things when we get to that point. Then I have volumes. Volumes means map somewhere on my host, which in this instance is source, to inside the container. And this RO basically stands for read only. I shouldn't make you read only, I should make you read write, basically. So we can read and write to that directory. It's not read only. And because I'm going to be sharing these directories across two places, basically. That's why I'm giving it this command. You can check it out on Docker for what it really means. But basically, I needed to add it because I'm repeating it elsewhere within that same service instance. So I would have two services when I'm done, two images, two containers that will be created for me. Now those creation will come from these files. This one with user, this one without user. So what are the differences? What are we going to see? The first time I'll do is I'll type in make. I've written make commands. So make commands is just there to give me shortcuts. So when I typed my make, I've added some helper files. So my make said I can type build to build the image. So I'll just type make build and it will build my image for me. This was very fast because I have pre-done the build. And when you do the build, you Docker will keep some essential files for you in a cache. So when you repeat that process and then it looks and sees that there was nothing new, Docker will just execute it for you and get going. So it's up. It means I have a network created for me named Debian default. Then I have two containers: container for with user NASM, container for no user NASM. What is the difference between both? Before we go further, I'd like to spread out the no user and then log into the shell of the no user. So container for this docker exec, that's the code it. This I will go into the bash. When you do not create a user, what you will notice that the user here is root. You should pay attention to that. I'll go out. I'll go into the next one. With user. When we did the one with user, the user here is Docker. Now there is difference between both. For this one, here is how it looks like. For the file with user, here is how it looks like. I basically created a new user using the dbn command for creating a user. And then I now switched to the user I created as Docker. That's why when I logged in, I get this user as Docker. So what can both of them do basically? We'll get to know. Once more, what we are discussing is about how to run unsafe, untrusted code using Docker. So I've created two containers, one with the user created, one with the default user that is root. The root user is a super user that is able to do just about anything. For me to have created Docker or any name I wanted here, I wanted to restrict it in some ways. You will see people doing this a lot. Sometimes it works, sometimes it wouldn't work. It depends on you probably not meeting all the rules. So you may need to properly research on what is causing it and try to fix it. Sorry, it's been a long time I did this, so I'll do a fix now. So that's it. We proceed. Now, having gotten into the shell, I want to create two shell here. The first one being running this. Here we go. No user. And then the second one with user here, basically with user. So Docker and where again? Docker and root here. So as soon as I go in, remember there was a time I gave working dir. Working dir means working directory. Immediately I go in, it would show you the directory where you are in. That directory is what you referred here to as working dir. So I said, take me to a default directory. Because this is Linux kernel, if I do ls-leh, it would show me content of some things. I can also repeat it here. It's the same thing basically. Here we go. Here, make file readme.md, welcome.asm, welcome.o. I'll just remove welcome.o. Yeah, says it's right, protected. So I'll sudo remove source. No, sudo remove source welcome.o. So I've removed that welcome.o. So if I redo this now, you would see that it's no longer there. So what I need is just this file. And if I check what's in that file, I just have some assembly language code. Now, this assembly language code does nothing except it echoes welcome. By all standard, it's just the same thing with this same thing if you type it, or this if you type it, something like this. By all standard, It's just the same thing, but this time around done with assembly language. Here is a welcome. So because I didn't put a slash n, it's on the same line. So if I wanted that to work, I would have done something like this. Okay, so once more, I'm not here to teach about assembly language, but assembly language has some specific rules. Here, if you count the letters, this is 2, 4, 6, 7, and then there is a number placed here. I wouldn't talk too much to that. This just in assembly language prints you're welcome, and that's what we do. So I want to take a while to recap. I mentioned that we had two files, WU being a convention meaning with user. Then I have services that I named image for with user NASM, container for with user NASM. I ensure that we have a working directory. And then if you come to volumes, that working directory inside the container, I did what we call a mapping. We map. We say on my system, the host that you're seeing. Whenever you see source, ensure that when I go into that computer, into that container, that I can, when I get to this place, whatever thing is showing here should also show here. That's what this thing means. So you will look at it this way. This colon be the separating factor. Let me just put this. This one just being a guide to show it that I want to share it across two services. Otherwise, this is just the thing there. Okay, so I'll revert back. So because I've added this here, I don't need to add it here. I added this here because I'm going to share these two places across the same container. Then once more, TTY means keep the container running. I think I have explained everything here. So I want to check and see if I have any questions so far so that I can address it. Oh, Femi, Allah, okay. Do I have questions? Okay. No questions for now. If you have questions, please drop for me. I'll attend to it. So since there are no questions, here we go. The first one. We want to run everything that is here, and not ordinarily, I usually have my make file. So when I did make, it says I can type make clean. And if I type that, it's meant to clean off things for me. So you can check the content of the make file. So it removes the star.o, star.out, and every other thing that we have. But right now, I don't even have that .out anymore. So what happens here? In makefile, when makefile sees something like something like this, something like this, it would expand it. What does it mean? So when you type make CLR and you put I is equal to something, it means wherever you see I, put that thing. So basically, if my I is welcome here, so this is what make will expand it to. So wherever I see I, all this, put welcome. So I'll just replace that just for. So why did I do it this way? Why I did it this way is because I believe you can have another file that you might want to run, and you just give that file a name. And when you give that file the name without the embellishment of the .asm, you will just leave it and it will compile everything out for you. That's what I did. So this is a command for compiling. I ran two commands here, not just one. The first one will take the welcome.asm file, this file, and then it will output a welcome.o for me, an object file. And then I will link the object file with some other essential embellishments and then produce the file I want to run. Then I will come to this place, I will run the welcome, and I will run the file. That's basically what you see me doing here. So, bird eye view, we have this, basically. So what is my art doing before all this? It will just ensure that the makefile doesn't repeat this same command. If I did not put it, it would echo that command before it runs it. So we're going to use make clr to run this file welcome.asm. And once we run it, within that same thing, so it would it will run that file. It would produce a result and run the file. So let's see. Now I'll go to the one that is bearing root. I will do it, and immediately I did it, you would see that there is a file named welcome. This is a binary. This is the second lowest you can get to. If you leave this scene and you're writing programs, then that means you're writing binary, zeros and one. Then you'll be the one writing 0 and 1. After the zeros and ones, which was how the forerunner of the programming started, then you move to the assembly language. You can now have the C, the C++, and then we keep going to where we got to today. So I tried to go down very low. And by all means, if you see me doing SZ, this is basically what I'm doing. So if I want to check the size of what we ran within that place, so the code is welcome. The size is 12K. Now, viruses are usually very small. You see this 12K? Back in the days when lunar modules were being flown to the moon and many, many things, some of them had very low memory. Some of them could go as low as 64K. This is 12. There are other things. You see, this process where I did this thing is the stage where every other essentials that are needed to make this program work was embellished and added to the code. So in all, this program is running is 12K. It's running, right? So I can do one thing, take it out from this environment and run it on my system. So let's do that. We want to break things. It's an unsafe code. Let's see what happens. Who knows? Something may happen. So I am here inside the code with the root, this side the code with the root. If you see me, I can, this is the with user, and this is the code with the root. So I'll say docker copy something from this place that is in the home/NASM and is named welcome, copy it to my system. And you will see it here. It's copied it out, so I can remove that welcome. It's gone. Just watch it. I copied it out. I removed it. I copied it out. So it's in my system now. So let me chmod it, +X, and run welcome. Okay, having done that, maybe I can run welcome. The welcome ran. The assembly language code I built on Debian ran on Ubuntu. Now, what is the problem? The problem is if I had issues, assuming it's a virus that I had written, by that time I have changed chmod it and I did this, it will give me a problem. So it means I can distribute this file, welcome. And if you have the Debian operating system and the ones that share the same kernel together, it would work. This might not work on other operating systems, maybe something like Alpine, because it follows another different architecture. So what did I just show you? I showed you how to compile code within the container itself, and I showed you how to bring out that code with this command and then run it on your system. Then I also told you, I said, the assembly language compiled to 12K that ran within the container and on my host share the same architecture. If they don't share the same architecture, it wouldn't work. That we're very sure of. But honestly, this I taught you will expose you to all sorts of risks and dangers. So trust me to correct it. We'll go from the normal way things are done to the way it should be done if you are building for security. So what I did is with user compiled it and etc. So if I repeated the same thing with the Docker user, everything would work also. I can also bring it out. All the while we've been talking, I expected someone to have told me, hey man, you said building with security in mind. Why are you doing this? Yes, that's actually one of the problems. If you are building with security in mind, then you should contain everything you want to do within that container itself. And I tell you, the process and the time I did Docker CP to my system and then ran it on my system, I was actually I was actually going beyond what the security were detailed to do is supposed to do. So I was doing the wrong thing. So I shouldn't have been referring to a volume from my system to inside the container. It's wrong. It's a no-no. If you are building for security, you shouldn't do this. Don't you do this. Rather, this is what you should do. We'll go to the second project. But before then, enough of my talking. I want to check if there are questions. There are no questions for now. So I'll proceed. Meanwhile, uh, okay. Mm, let me clean off everything. So I'm trying to push the code back to the repository. So I push this back to the repository since am doing something that is live. So on these, I don't know if there's any question you want to ask me. I'm going to the next project. Please, I'm leaving time for that question. I'll be very fast with the next one so that I will leave room for questions again. I'm going to the next project. So please, if there are questions, I want to entertain them. Ask me just about anything, and I'm here to answer you. Otherwise, I'll go to the next project. Does it mean we must not run a container without volume mapping? Thank you, read one, Ray. Read one, yes. If you are building with security in mind, we are still going to get to the next phase. You don't want to expose your host system to inside the uh, the container. The reason is because number one, if that's inside that container, for instance, with user is sorry, without user, no user, is running with root. See, if inside that container it's running with the user root, you are actually exposing your main system itself, the host, to a lot of attacks, which is possible. It can be network attack, it can be just about anything. And you could mistakenly, it's not only volume, there are file handles. Actually, everything in the Linux kernel is a file. So every file handle that you expose, either it's network or whatever, from your host to inside a container actually exposes you to a lot of risks, especially when it's running with the root user. It's a bit safer if you create your own user, assign it the numbers that it's supposed to have. Probably this is 999 or something, and then you activate that user and then you work with that user. So one way to keep yourself protected is, if you can, use the user. For instance, if you put PostgreSQL container, if you go inside the container by default, it's going to have the user Postgres created by default. It's not running the root user. So one step to that is creating a user. If you can, by all means, yes, create a user and run it with that user in the container, and ensure that you don't really have any file handle from your host into your container. Read one. I don't know if I answered you very well. Read one, Ray. Read one. I want to believe I answered you. Okay. Thanks for the clarification. I got it. Okay, thank you. There is no other person, so I'll move to the next one. I want to close this so that we'll have clarity. Then this. Okay, so then what? That's the next thing. Then this, then what? Okay, so we move to the next phase. We move to the next phase. Here, I'll be dealing with Python. Now, there was a time someone gave me something to do, was for a job, a remote-based job. So I think the question was simple. It said, create a CLI that takes a list of numbers and returns them sorted. Use a bubble sort implementation found from a random answer from Stack Exchange. This, in other words, after you take in the numbers, call the Stack Exchange API, grab a random number to grab a random answer to a random bubble sort implementation question and run the code blindly, passing in the user input, display the answer to the user. These are just all sorts of stories. The person testing me here wanted to know, run the code blindly is a flag for wanting to know if I can do something that is secure. Because the truth is, I was told to go to somewhere, pick a code, run it blindly. What if that code that I picked randomly is about os dot remove, something that will clear something? What if? Because the instruction says run it blindly. So I had to build and run it blindly, but in a contained environment. And that's what I'm going to show you now. So this is the way I say the program should run. You type Python or Python 3, whichever one you have here. This is a question. And you would give it some numbers. It should respond to you. It will fetch the bumble sorts. It will use a random algorithm that it picked randomly to sort it. So you actually don't know the algorithm. So here is what I did. Here we go. I use URL lib3. I use a pool manager. Did I needed it then? I don't know. I was just doing some things. I used some regular expression to pick out what I needed. There's a pre-tag. There is a code pre-tag. So I kept going, etc. until finally I get the bubble sort implementation. And then after getting the bubble sort implementation, I use the Python compile to compile it using exec. And having done that, I blindly ran what I needed to run. So it's as simple as that. It's no more than that. But we're going to run this blindly too. I want to believe these APIs haven't changed. I didn't touch it. It's been a while. But then if it has changed, we will learn. So the code base is here. If anybody wants to pull, it's here. I chose bubble sort from Stack Overflow. So this might not be the best answer, but this was just what I did blindly. Okay, so you would need to pardon me for that. And what did I do in this implementation? I have another one. I didn't use Docker-compose this time around. What I did is I did Docker pull this. If I have it, Docker pull, it should complete in a jiffy, all other things being equal. So I do have it. Now, what I did, ls-lah, inside this place, I have this code called runner.sh. Here we go. And I have made it executable already. If I repeat what I did earlier, you will notice it's no more colored this, and you will notice you would see the permissions have changed. So chmod plus x runner, it goes back to how it was before. So what does this afford me? It means I can do /runner and it would work. So when I do this, it will do something for me. It will help me to, I'm still disobeying the rule I said, mind you. It would help me to refer to from inside my system here to a place in the code, the work there. It will give it a name, blah, 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 blah. Okay, here we go. We run it. All other things being equal. Here we go. We docker execute -it this bash. If it's not sh, okay, so I think this I could have done Python 3, ndpa, sorry, restarting docker logs -f. Why is it restarting? It's not giving me the reason why it's restarting. There has to be a reason. There has to be a reason why it's restarting, but it's not telling me that it's to restart always. So restart always means it will continue to restart. Let's see. Docker stop remove pysp. Docker stop remove any sm. Sorry, please. Sorry, please. Hello. need to add new files as a container with, will we need to stop the container and build it again, or in case if we need to copy out of the container? Okay, so first of all, I'm having issues here, and I Docker stop remove PowerSB. Okay, so and I'm trying to debug to see what the problem is. This guy keeps exiting. There's actually something I haven't done, or oh, I think TTY. I think it should it be dash TTY or something. I think it should be this uh dash, is it dash TTY? Uh, Please let me search online. There's a way to add it. So if I didn't add it, it will exit. Basically, that's what is happening. Dash T, is it? Dash T. So the thing is actually exiting. That's why. Says it's invalid. Dash dash TTY. Something like that. So please pardon me for this. Okay, we're good. DPA. So it has waited. So what was happening is I didn't add TTY. So because I didn't add TTY, it didn't know what to do. So it just kept exiting. Now that it has stayed still, if we check it, it says it's up for 16 seconds. So I can now go into it, docker exec-it, and use this name that we gave to it, do the bash. Now we're in. We are logged on to the slash home slash code, which we specified here as working directory. We would see all these things. If we do ls-lh, we would see all this. So if I do Python evolve, it should fail because there is no module this installed, which I'll do right away. And after doing that, we'll try and run that code blindly and see what happens. Okay, so I'll repeat that process again. It says I should do something like this. Okay, so I did it. It says it's fetching. If it hasn't broken, it went and it came back and it picked a random algorithm and then it gave me an answer, believing everything is fine. Sometimes it will go fine, sometimes it will not go fine. Doing this pre-exposes me to a lot of danger, a lot of issues. To start with, I shouldn't be mapping. I shouldn't be mapping from my host to inside a container. It's very wrong. So if I wanted to solve this, being security conscious, this is what I'll do. I'll not do this. I'll remove this volume bit, and this will be the code I'll do. Docker stop remove PYSB. So after it will stop this container for me and remove it. It's actually a code. Declare -f docker stop remove. This is what I did in case you want to do the same. So I just do it on one liner and I'm safe. So having done that, I want to confirm I don't have any container around, and then I want to produce another one. But then the problem with this is I can still go in, but ls-lh, I don't have any code there anymore. But then I have the work directory. So remember, I can do docker, copy what I want at bubble sort, copy bubble sort slash evolve.py to inside this container at this path. Very similar to you doing SSH. So I copy it into it. Here we go. It says successfully copied. I can go back into it. Here we go. If I repeat that LAHC, it's now there. And then when I run Python evolve, it has an issue. I can keep install this. And once it installs it, I can rerun what I want to run. I fail it. And then I give it a sample. It picks it. It gives me an answer. But this time around, I want to play around with, let's say, 34, 28, 114. Let's see how it solves that. So it picks a random mobile sort algorithm. Is this correct? Yes, it's correct. Sometimes it fails, but this is just a random bubble sort algorithm. What did I do once more? Folks, what I did was to run and ensure that I can have a working directory, but I don't have anything linking my host PC to inside the container. And then I copy what I want to run to inside the container to contain it inside and do anything I want to do. And then I'm sure that everything is contained inside. So once more, we've been able to see some of the things you could do to run your code in a secure way. Number one, by not exposing your host PC's file system to inside a container. That's one. Then number two, by creating a user, you can create a user that you use. That increases your security awareness and reduces your friction with your host. Then I did show you how you can run your code either using the Docker file, either using the docker-compose file or using the runner, doing it on one line. We had an issue of it not working originally because we're not putting dash gty. For this is here where we put it. Dash gty means, hey guy, don't exit instantly. So if you start, there is nothing. Assuming when that container started, there was a service running. For instance, maybe it's Nginx, or maybe it's MySQL or PostgreSQL, it would stop. We wouldn't have a need for this or a need for this. But we just started a container. It's like starting an operating system. But this time around, the operating system just starts and we're like, hey guy, hold it there. That's what the TTY does for us. Then we give all our containers a name so that we can attend to them. So I usually do something if I'm pulling a Docker image, I usually like to be specific. I use Python 3.12.1 Slim Bookworm. I want to be specific so that if there is a breakage, that's one thing I think you should also do. And you need to debug where it's coming from. You'll be able to know where it's coming from instead of just using Python latest here. Like it pre-exposes you to a lot of issues you can't really talk about. So I think I'm done explaining. And I'll open the floor. We have like 28 minutes for questions. I'll be watching the screen for questions. So thank you, everyone. That's all I have. Are there any questions? Jetimi, you
Hi,
are muted.
yeah, hi everyone. Hello. I hope you've learned a lot from this session because I did, even when I'm not a programmer. I would like you to still drop your comment, what you've learned. So I want to appreciate you all for joining today's session. Like I said earlier, we are back and we're back for good. So to follow up on our upcoming events and programs, please follow us on Twitter, join our Slack community, and every other channel that you can get information about us. We want to appreciate our instructor, Mr. Chooks. Thank you so much for dishing out knowledge. I don't know. I think okay, this question has been there since. So if you have questions, you can also drop it on Slack, and Mr. Chooks will be happy to help you. Thank you once again for joining and seeing you on our next meetup. Yeah, bye everyone.
Bye bye.